Old versus new. Shiny brass. Hello Internet, I'm Guy. I'm back on the steampunk conversion for my Stirling engine here, and I've got a few things I want to change. So I'm going to work on replacing the piston here and the piston rod with brass. So I'm going to turn a new piston rod out of brass and this piston connecting rod. I'm also going to change out the pin here that was originally stainless steel, and I reproduced it in stainless steel, and then I changed my mind. So I'm going to use a little 256 bolt with some hobby brass tubing over it, so the brass tubing will then ride around that and give it a better friction bearing. So if you take apart this part here and pull that off, you can see that the cylinder, very strangely, is made from ground glass over metal. I don't know what kind of metal, but of course the pin is trapped in there. There's nothing I can do to get that out. So I'm going to make an exact reproduction of this cylinder, outside diameter and length, and also cut a slot in here and fabricate the arm that fits in here and pin it in there. That's the project for today. So I'm starting with a piece of 1/2 inch brass, and the piston diameter is 0.4905. So I don't have much to turn off. I'm going to be using a round end cutter because it's going to make a nicer finish. And get that dialed in, zero out my DROs, and I'm just going to hand turn this. I know I need, let me just see what length I need here. 0.521, okay. So let me just mark that off while we're not running. Like that. That's good enough. Okay. Alright, so I'm measuring 0.490, so I'm already there. Let me check the cylinder. Guess I was more aggressive cutting than I thought. That is actually spot on. That was lucky. Okay, so I'm just going to surface that a little bit and then start to part it off. Chamfer the end a little bit. So I'm going to bring in a file and just round it over just a little sweeter. And bringing in the parting tool, get that set up about here. I'm going to double check my length, which needs to be 0.517. That looks about right there. Close enough. Now I need to take it out of the jaws and go over to the mill to cut a slot and the pinhole here for the shaft. So I'm going to make a little mark to know which jaw this was on, because I want to be able to grip the whole shaft here and then bring it back to finish cutting it off. So in order to make this slot, I'm going to use the slot cutting mandrel that I built when I first got my mini lathe. And I got a bunch of slot cutters from some kind of eBay supplier. I think it was some old guy who was selling off his shop. So now what I'm going to do is use the fly cutter, or the slot cutter, sorry, as a basically a finder for, you see how I'm deforming the cutter? Let me just zoom in a little bit there. Right there. If I come down and just push down very slightly, you can see the cutter head deforming slightly. So that's my 0 for the vertical axis. And then I'm going to back off. Come down. Oops. Come back over. And right where it bumps and moves, that is my other parts. That's exactly 0.5 on my DRO, as it should be. So now I can drive it to the half position on the DRO. So I want to go 250 right there. So in order to set the depth of cut here, I'm now going to creep up against the cutter, and that's my 0. And I want to go 0.2 inches in. So back out over here and 0 my y-axis, and then move in about 2.2 inches, something like that. Ready to cut. Here we go. Moderately slow speed. Gonna tiptoe through the brass. Alright, that looks good. I'm gonna back all the way out again. I've moved the cutter up 0.02 inches, and I'm going to make one pass above and one pass below. Looks like I went a little bit too low, so I'm going to come back up and do another pass. So I need to center find for the pin I'm going to put in here. Right there. Set my DRO to 0. Come on over. Right about there. Divide that by half. And set that to 0 on the DRO. Right there, lock that down, and then I'm going to swap out for a milling cutter and make a little surface there. So now I'm going to take about 15 thousandths off of there. Drilling a center drill for the pin that will pin the piston shaft. You can see the marks where I had identified how this went into the chuck originally, so hopefully I'm maintaining concentricity here. And I'm going to realign my parting tool into the original slot and part this off. Removing the old stock here, and I'm going to just very gently put this cutoff piece in the jaws, and I'm just going to finish off that surface right there. And here we go. If you're enjoying my video, please give me a like or subscribe. And now back to your regularly scheduled program. So now I'm working on the crank arm. So I've got a 1/4-inch piece of brass strip clamped up in the vise, and I'm just center finding to the center line of that. I also have some scratch marks, as you might be able to see right there, which are the spacing for the holes at each end that are critical to the design. So I'm going to bring in my centering drill and drop some holes in those 2 marks. One of those holes will be the smaller hole for the pin, and the other one will be for a piece of brass tubing that will be held in by a 256 screw, and the brass tubing will rotate around the screw, making a slight bearing effect there. So here I am going to the second hole, just getting them started. So I'm going to drill out the 1/8-inch hole for the brass tubing that wraps around the 256 bolt on the pulley, and then the other end will have a pin that goes through the piston, and that will be a smaller hole. That's coming up next. So now I'm going to center drill a series of holes equally spaced, and I'm going to interconnect those holes by milling through between each pair. So I've center drilled them all. I'm drilling them out to exactly 1/8 of an inch and working my way through all of those holes. So now I'm going to use this milling cutter to connect these two, these two, these two, and these two, and I'm actually drawing it in so I remember which ones I'm doing. So these will be little oval slots that should be really attractive, hopefully. Well, that first one looked a little rough, but I'm going to try again, maybe running the cutter a little faster this time. Still looks a little messy, but I can clean it up with a file probably. Well, I'm not too thrilled with how this turned out. I would like to be able to have neater holes in that, but I think I can file them out. It's cleanable. In fact, maybe I can just surface mill this side. I'm not sure yet. If anyone has any thoughts in the comments about why this is galling and struggling, I'd love to hear them. Okay, so I've cleaned it up a little bit with an X-Acto blade, and then I'm going to try rounding over the ends at each end here because that's what it needs to follow that radius. And then I might try something where I can hold it against the sandpaper safely, maybe set up something here. So I need to shorten this 256 bolt a little bit because I need the shoulder for the bearing, but not the rest of the bolt going all the way through the pulley. Well, that didn't take long. So I managed to clean up the piston rod fairly well. It doesn't look too bad. These are all the parts now. The pulley, this is the little roller that will run around this bolt, and the washer to hold it in, the piston rod, and then the piston. So I'm now going to start by putting in the piston pin. Drop this in and find it in there. There we go. So now it'll go into the piston and it'll work just fine, and if I put my finger over the end it's sticky, so that's a good sign. So now I'm going to take this little bolt, put the shiny brass washer on it. This is tiny stuff. Then this, by the way, I parted this little tiny piece of brass tubing off on the lathe. It was the simplest way to get a nice clean cut on it. So now I'm going to tighten that in there, he said. Yes, okay, there it goes. I'm going to have to put some thread lock in there, but I want to make sure that it goes in far enough and doesn't stick out. It does stick out just a tiny bit there. So I think I'll go ahead and grind off some of this. This is going to sit off camera, obviously. I think this is more stick out than I need here, so I'm going to cut down the brass a little bit and cut down the bolt a little bit and come back and finalize this. Okay, so I've got the little brass tube shortened down. I've got my brass washer installed on the bolt. Now I'm going to mount the bolt through the piston arm and then hopefully drop this into there. I'm going to use some thread lock eventually. There it goes. Alright, use a wrench. Right, so eventually, get that old piston out of the way. Excuse me, let me bump the camera up. This will now sit on there, and this little tube slides onto the connecting tube, hopefully. There we go. Right, yes. Okay, so now this comes up on here. Okay, I've got the belt on there. This is looking promising. It's not making bad sounds. So now I'm going to take the Phillips head screws that came with the kit and secure this base temporarily back into its original hole there. And the same with the other screw in the back. Eventually I'm going to replace all of this with a brass cylinder there. This is looking good. Okay, give me a moment. I'm going to fire up the flame here and see if this runs. It's all heated up now, so I'm just going to tick it over, and there she goes. So skipping ahead, I've already made a new brass piston and the connecting rod here. I did a quick test to see if this was going to work, and it doesn't seem like it's going to. So I'm going to go ahead and light the fire here, and I'll be back in a second. But first I wanted you to see the original cylinder, which I finally realized has two O-rings in here so that you can actually pull that out. So I have another option if this doesn't work out of just making this part, or in fact just turning down this cylinder and making this part. So let's see how it works out. I'm going to be back in a second when it's warmed up. Okay, it's warmed up and I'm trying to kick it over and it's just not working, and I'm really not sure why. I have a feeling maybe this brass is soaking up so much heat that it's keeping it cooler in there, or there's just too much mass. I'm feeling a lot of friction in the movement here. So I think I'm going to fall back and do what I spoke about earlier, which is just to replace this little part of the piston with the existing brass and see how that works out. I like this connecting rod. This came out pretty well, and I'm going to shorten this little connection here later just to make it smaller. So I've learned a couple of lessons. First of all, my little piston insert that was holding the silicone O-rings was a little off spec, and so when I tried to use it, it was creeping out and then pushing the cylinder too far over, and the whole thing was jamming up, slowing down and stopping. The other thing is that the little pieces of brass tubing I put here underneath the bolt, which are designed to be a little bearing essentially, were off spec, and so the ID of that brass tubing was too large. So these are the parts in question here. So I actually had to machine brass here to make the perfect 1/8 inch ID and 0.081 ID. And now it runs a lot quieter. There's still a little bit of thumping. But it's running great, so I'm very pleased.